So,
And I started recording, and I think it yells at you for that. So,
yep, perfect. Thank you.
hmm?
So, my name is Yogesh. I started tinkering with Linux in 98 when it wasn't RAL, used to be called Red Hat. The first version I encountered was 5.0. I've been using Red Hat since then. These days I use Fedora distribution so I can test what is going to be Red Hat in future. While working on Red Hat, we started looking at the database solutions, and one of the solution I liked internally in 2000 is PostgreSQL. I started playing with it, and then I joined Crunchy later on. And while working at Crunchy, we were asked, can you create an HA distribution? We looked at a lot of different solutions, and we said, why to create a new distribution out of it? Why don't we assemble open source products and create HA solution out of it? And that's what the Crunchy HA PostgreSQL is. Usually in enterprise environment, when you want to run PostgreSQL, you have to do a lot of things. Provisioning, that means create, destroy, configure, administrate, upgrade, and other things. You need to have HA capabilities so that you have a better uptime. You can scale, that means you can add more nodes as required, and automatic failover management. On top of that, you also need to think about disaster recovery. You have a HA in one data center. What happens if your whole data center goes down? How do you recover from that? Backup, restore, or maybe a standby data center. Nothing is good unless until you keep a tab on how the health is, right? That's what's going on these days. Everyone has to be careful that they are not affected by corona, right? So same thing for database also. You have to make sure that your database is healthy. You need to collect health metrics and make sure that before the problem becomes critical, let's fix it. Management, like performance tuning, access control, user connections management, and etc. So that's like just the enterprise PostgreSQL. If we dig deep under that part, just running a Postgres single instance of Postgres cluster is not an easy thing. You need to make sure you have set up your repositories, install the software, execute your initdb, periodically update your PostgreSQL config file or PGHP config file. And you have to also manage security patching, user management, database management. And if you take that and multiply by a number of HA clusters and nodes in HA, it's too much of work to do. So that's when we worked with Red Hat and created Crunchy HA PostgreSQL, which allows us to easily deploy HA cluster. I am going to launch a live demo here. So what I'm using here is a tool called TTYD, which allows me to bring my terminal to the browser. So I have multiple browser window open here, tabs here. Here are my 10 nodes. I have 3 HCD nodes, one HA proxy node, one node where I'm going to install monitoring, and my 3 Postgres nodes, backrest and bouncer. Only thing I have on these nodes is operating system installed, my SSH key is set up so I can use Ansible SSH connection, and sudo access so yum can work. I'm using 7.x CentOS here. It works with Red Hat 7.x or CentOS 7x. All these nodes are started using libvirt, which is a KVM based solution. Playbook, and I will pass it my inventory file here. So I'm going to set up 3 node HA cluster. And while this runs, it takes about 6.5 to 7 minutes to set up all the 10 nodes. While it's running, we will talk about other things on HA, and I will go over all the components that are part of this HA cluster. Okay, looks good. Looks familiar to all the Ansible folks, right? Okay, so while demo is running, let's talk about why to use Crunchy HA PostgreSQL. We have created an automatic framework for you. We have created roles, which helps write our playbooks very easily. It allows us to create HA Postgres cluster, which can be in a single or multi-data center environment. And I have different deployment scenario that I can go over in subsequent slides. You can create a standard environment. That means all your HA clusters can be pre-configured in a way that they look alike. You can do cookie cutting kind of mechanism here because that's what the Ansible is designed for. You can apply same rules to n number of nodes, and we are utilizing that. Deploy synchronous or asynchronous replicated clusters depending on your requirements. Uniformly apply your compliance rules across all Postgres clusters. Everything is based on 100% open source components. Nothing is proprietary here. What are the components here? Number one component here is Crunchy certified PostgreSQL. Of course, we are talking about database, right? So we have got the common criteria EL2 certification for PostgreSQL. We also published a STIG. We have published it for 9.x releases. We are in progress of working on 10, 11, and 12 STIG release. We are the first one who published the CIS benchmark, which is all updated up to Postgres 12. Second component we use is called PG Backrest. It's designed to handle multi-terabyte scale databases. It helps with the database backups, as well it also helps with write-ahead log archiving, which helps us in point-in-time recovery. In case if something got dropped, we can go back in time, recover it. Third component here is PG Monitor. It provides a robust key database health monitoring metrics. It's based on Prometheus, Grafana, and exporters. On top of that, we have created our own set of queries and configuration metric that helps us create the key metrics from databases. Fourth piece is PG Bouncer. It's a special connection pooler designed specifically for PostgreSQL. It has a lot of good features, like you can pause and resume connections as you are doing some maintenance work. HA Proxy is a performant durable TCP load balancer. It helps with two things in our design. First, it's going to detect where is my read-write primary node, and it will redirect connection there. Second thing, if applications are aware of read-only concept, they can utilize replica nodes in a round-robin or different load balancing configuration to execute read-only queries on those nodes. Part of whole HA is Patroni. It's an open source piece of software written in Python. It's a HA framework for PostgreSQL. It's going to manage Postgres instance. That means we are not going to run Postgres as a service, but we run Patroni as a service. And in turn, Patroni uses etcd, leader election, and then it detects who is the primary node, and that node is going to in turn start the PostgreSQL. So Patroni is like a manager here. etcd used by Kubernetes, OpenShift, other things, and we also use it for distributed key value store. So etcd is like source for all the information. That's where we get right information from, and heavily used by Patroni. Here's a pictorial view of this HA cluster. At the heart, we have 3-node Postgres running, managed by Patroni, and the PG Monitor. Basically, PG Monitor here is set of exporters. We have 2 exporters running here, one for OS metric collection called Node Exporter, and second is PG Exporter. or Postgres exporter, which collects database health metric. We don't use default metric from Postgres exporter. We have our own set of extra SQL scripts that we provide to Postgres exporter, and that's the metric we collect. So as Postgres Patroni is managing PostgreSQL, it has to make sure that critical information about all these clusters is available to all the nodes. And that information is stored in etcd. To give you an example, what is my database ID? Each database cluster, when you create, it gets unique ID. That ID is stored here. What is my replication lag between primary and replica? There are critical 10 special parameters that are used by PostgreSQL and Patroni, which has to be same on all the nodes, because we don't know when we are going to promote one of the replica to become primary. So that kind of critical information is stored in etcd. As and when time comes up when Patroni has to execute a leader election, in case this node dies, it also depends on etcd for that part. So a lock will be placed and then election will happen, and whichever node wins the election is going to be the new leader, and that will promote itself to become the read-write node or primary. All the metric that's been collected by PG Monitor goes to Prometheus and gets stored there. Alert Manager is also available for alerting, and you can visualize that metric using Grafana dashboards. And we do provide prefabricated dashboards. As database is working, its transactions are happening. It doesn't write everything to data files. First, it writes to write ahead log, and later on, the background writer is going to take that information and write to data files. So as it's creating these write ahead log files, it's going to ship those write ahead log files to backrest, and backrest is going to store it at some repository location. That can be your NFS, your local attached storage, or S3 bucket, anything. Backrest is also going to be used for periodic backups. It supports full incremental, differential, and other backups. And I was saying HA proxy. In current setup, I'm only going to run one HA proxy, but we usually recommend running a set of HA proxy so that this doesn't become a single point of failure. And same thing with the PG bouncer. HA proxy is going to do redirect connection to correct primary, as well as it can also do load balancing for read-only. All the applications, they talk via PG bouncer, HA proxy, and goes to database. In case if your application already has a built-in connection pooler, you don't need bouncer, you can skip that one. And if you're not utilizing any of the special features from bouncer, you can eliminate that. In case if you have already invested in F5 or NetScaler, we can bypass or remove HA proxy also. There is other option that you can also have a virtual IP between these nodes, and you can eliminate HA proxy. But when we are working in a single data center, that works very well. But if you stretch your cluster across 2 data center, you don't necessarily have an opportunity that your WIP will be migrated to the second data center. So that was the one reason by default we talk about HA proxy and not virtual IP address here. Any questions so far? Let's go to next slide. As you all know, Ansible, it allows you to do automated things. That means we have created roles and playbooks, and they are going to help us deploy all the components. With Crunchy HA PostgreSQL, you also get resilient database because automatic failovers are there. Not only that, in certain scenario, automatic healing is also possible. The way we have created our playbooks, we automatically include PG backrest for backup and recovery. So if you are storing your backups in S3, you can easily recover anywhere as long as your S3 bucket is available. So you have a DR capabilities there. Connection pooling using PG Bouncer. Load balancing using HA proxy. Monitoring and alerting using PG Monitor. We heavily depend on Ansible, and when I go to live demo, I'm also going to show you a lot of things that you can usually type for the things to do. We have converted them to scripts, playbooks, not scripts, playbooks. This setup is going to deploy full HA stack. It can go and configure SE Linux. By default, we don't suggest disabling SE Linux. So we have put hooks in place for certain things where SE Linux context has to be changed or opened up for certain things. These roles are aware of that. Firewall ports can be automatically opened on Firewall D. Installing, configuring PostgreSQL, installing and setting up HADR, setting up monitoring, fully automated. When it's detected that primary node is down, Patron is going to pull the plug on that node if that node is still running. If that node is completely dead, that means hardware died. That's a different case. In that case, other nodes are going to have election, a leader is elected, and a new primary is selected. In case we are doing controlled failover or to say switchover, we pull the plug on current primary and promote one of the best replica that is farthest ahead. Automatically repair is part of a whole setup. Let's say if you lost your data volume where your database data was residing. Later on, you fix the volume and attach a new storage there. It can automatically restore backup and bring back that node in HA cluster. Or if you're adding a new node, it can reconfigure that node to be part of that HA cluster. A lot of automation is in place. For disaster recovery, we heavily depend on PG Backrest. It's a leading backup restore tool for PostgreSQL. It's written by one of the Crunchy colleague. And we have thought a lot about what needs to be get done and all those features that are specific to PostgreSQL and how to optimize backups are in place. It supports full incremental differential backups. It's the only tool that does a multi-threaded backup and restore operations. And it can also do a lot of operations in async manner, which no other tool can support. It supports point-in-time recovery. It got built-in backup integrity validation, compression, encryption, archive expiration, and rotation features. It's a Crunchy sponsored product and open source. PG Monitor is designed to capture PostgreSQL cluster health. We use Prometheus for metric collection, alert dispatching, and metric distribution. Alert Manager is going to process alerts that are being generated by Prometheus, and Grafana for metric visualization. Here's one of the eye-candy view for the Grafana dashboard. This is PostgreSQL detailed overview. Here you can see the backup information, which talks about time since last backup and other things. You can also look and see what are your table sizes. You can pick and choose what schema DB you are talking about. Here you have information about insert updates and delete on per table. And you have choice to pick and choose whatever schema you're talking about. This is one of the etcd dashboard. This is the main overview dashboard, which talks about 4 panels here: OS, Postgres, Prometheus, and etcd. Here's OS overview dashboard, where all my 10 nodes are up. This is animated GIF here, but we will go in live also. OS details and other things. So when we were designing these roles, We were not thinking about a single setup kind of thing. We're thinking about let's build something that can scale up. This was the initial diagram we started with. It's a single data center, single cluster. This is my HA cluster, and what I usually call these surrounding boxes as infrastructure services. Why? Reason, I can have one or more boxes like these, and I can have more than one HA clusters running. Something like this. On the same node, I can run two PostgreSQL instances. They may be same version or different version, but still my infrastructure is almost the same thing. Or if I'm looking for some sort of data separation between these two databases, that there's some policy that I can't have both databases on the same node, I can do something like this. Still my infrastructure utilities are same. Or I can do mix and match. As you can see, we have different way to configure HA cluster. Using the same roles, we tweak our inventory, our playbook, and have a different setup. So far, we have been only talking about a single data center. Everything works great in single data center. What about like in a financial institution, you have to have a disaster plan. And periodically you need to do ping pong testing. That means you fail over to your disaster DR data center, test out everything, and fail back. You can do something like that. Here I have active data center on the left and standby data center on the right. We did some extra connectivity here. As you can see, these two dotted lines at the top and the bottom. I'm going to explain these two lines here. First thing, what happens if my network is broken? I'm not going to get that application data to this side. At some point, my standby cluster may be out of sync. There are a couple ways I can handle that on Active Data Center. I can either create my replication slots, but then I'm afraid that if my network's gone for a longer time, I might be filling up my disk space because it has to keep all those write-ahead logs until that replica comes back and takes it from there. Other option is wall retention. But that's also like if I say retain n number of walls, it's always going to keep that many walls and I'm wasting my disk space. Third option is we can have our DR storage synced across two data center. That means all of my write-ahead logs from active data center are synced up here. And the way we have configured our database is that it also looks for write-ahead logs from backrest. So in case this streaming connection is broken, Postgres is going to get an error that the streaming connection is not there, and it will go talk to backrest and say, hey, I need this write-ahead log. Do you have it? Give it to me. And it will start pulling those from here. Update itself. When it gets to the point where it has applied all the write-ahead logs, it will retry this connection and it may succeed. Maybe network is up. Second thing you don't want in your cluster is that your standby to be affected by any failover that are happening here. So that's the reason our connection is from via HA proxy. We're not directly talking to this primary here. So on left side, we have a one read-write node and two read-only replica. On right side, we still have a leader, but that leader is a replica. Other nodes are doing replication locally in a cascading manner. So I'm not adding extra traffic. Since I'm routing through HA proxy, my standby is not affected by any failovers happening here. It doesn't have to reconfigure that, hey, my node B is now primary. Let's go talk to that node for streaming. We thought about a couple things and we put these things in place like this. And all of these example diagrams that I'm showing, they are real life example from our clients. They are running these scenarios. What if I want to stretch my cluster? Rather than having an active and standby, what if I stretch it? So the key difference between active is that these two are independent clusters. As you can see, each one has their own HCD, and there is no connectivity between these two HCD nodes here, either side. They have their own Prometheus, Grafana, etc. As we stretch cluster, it can be done, but it has its own pitfalls. We have to think about a lot of other things. Network latency is the key part. Second thing we have to think about is a split brain scenario. We don't want two clusters to think that they are primary. As you see, as we are progressing, our diagrams are getting complex. Here, HCDs are talking to each other. And I do have a third one or more HCD running in a third data center. This acts more like as a quorum HCD. There's less likely chance that all three are going to go out of connectivity. And we always try to go with the odd number of HCD. So in case if we lose quorum, then neither data center will going to say that they are primary. So here we have multiple connections from HA proxy this time. We have, rather than having just one connection, we also have a connection going to this side. Also, my replication is directly from node to node, not via HA proxy. In a way, if you look at it, this is like a poor man's multi-master also. Because here applications are writing via PG bouncer goes to HA proxy and to be redirected to this primary node. If this application is writing HA proxy, this HA proxy knows primary is not here. The traffic gets redirected to this data center. Any questions so far? Okay, let's go to the last slide, which is similar to this one. If I take this slide and combine these two, I can get something like this. This is also a real life example from one of our financial clients. More complex, more connections, and it's across continents. They have two data centers in US, New York, LA, and they have two data centers in London area. London is always treated as a standby. Within US, this is a stretch cluster. They have a primary and a replica. Then their requirement was slightly different. That means their use case is slightly different compared to all other online OLTP kind of applications. They are more as a data warehouse. So in case if they have a failover, once their application is stopped finishing current job, they will stop applications here and start it locally here. So they are not routing all of the traffic to across that data center. Otherwise, combination of previous two slides becomes this slide. Hey, let's get into live demo. Before get there, I have 3 node HCD, 3 PostgreSQL node, 1 backrest node, 1 HA proxy, 1 bouncer, and 1 PG monitor node. Let's look at how did it go. Okay, it completed. 6 minutes 12 seconds here. Nice. Let me bring up my monitoring screen. And I'm going to log in with my super duper secure password, admin, right? Here's my overview. I'm going to open a couple tabs and show you monitoring. Then I'm going to go over other live demo part where we do the failover, delete our storage and other things. So here's etcd. Let's do last 30 minutes here. Yes, etcd has a leader. Number of leader elections 1 because we just set it up. And your RPC and other metric is available. I'm not an etcd expert, so I can't talk much on this one. So I'm going to close this tab, go to OS one. Hey, look, all are green. All nodes are up. Let's go to one of the node here. Here, my system load, CPU usage, memory, swap, file system usage. I can also further drill down and get more details about my file system here. On this screen, I have my percentage usage of file system, free space, file system space used, my disk I/O per device, disk throughput, I/O time per device on the 5-minute average. All this metric that you're seeing can be used for alerting purpose too. Let's close this also, and I'm going to close this file system and database. So let's talk about database here. I have a primary and 2 replica. Are we sure? Don't know yet. Okay, let me see. I'm going to execute one of my playbook here. I'm executing a list command here on my HA cluster. Okay, it ran successfully and it shows my cluster is called Crunchy. I have 3 members, PG1, 2, and 3, running on IP 16, 26, 36, and 16 is the leader. I have other tabs open here. Let me access to 16, then to 26, and then to 36. I'm also going to connect to my backrest node. Okay, I'm switching to Postgres user on all these systems. And I can also run same thing from command line. I used to show you over command line, but recently I started using my playbook because that's better approach. We are talking Ansible. So as you can see, we have clearly identified that our leader is 16. And that's also true on this chart. Let's look into the leader here. We need to click open here. Okay, this is database detail metric page here. I have connection information, which gives me max, active, idle, and idle in transaction. Database sizes. I'm going to open up this in a new tab, which is going to talk about table sizes, my transaction per minute, the application byte lag. This is only available on primary node, which is read-write. The application lag, which is only available on replica node. So for primary, this is going to be pretty much blank. But once we fail over, we'll see there are gaps on both sides of charts and different information showing up. Commit versus rollback information, your cache hit ratio, my create, read, update, delete per database. Let me click here and open up this also in a tab. Then my conflict deadlock, my lock information, buffer information, my wraparound information, and emergency vacuum information. My total wall size and vacuum analyze information. So I have opened 2 tabs out here, and there's one other that I'm going to open, which is my backrest one. So Here you have an option to pick and choose which cluster, which schema, which DB, which table to use to look at the information. You can pick and choose any tables in your cluster and look at the information. Similar to that one, you also have a insert, update, delete per tables. And this is an interesting one. When was the last backup taken? Backup time, your backup size. These are a couple good dashboard items here, which can also be used for alerting. Because you don't want your backup to take longer than 24 hours, that means something is wrong, right? And if your backup size is growing, you need to keep a tab on that and make sure you have expanded your storage. So let's close these two ones out here, this one also. And I will leave this one open here, and I'm going to just tweak my time to be 30 seconds here, refresh rate. So right now my leader is PG1. What if I want to change that leader role to PG3? I can do it here manually, but let's do it using a playbook. I'm using -E extra arcs. You can see the bottom of my screen, right? So I'm going
Nope,
to
it's
pass.
hidden.
It's hidden, okay. See if I can make it slightly here. How is it now? Or actually, let me do one thing here.
Good for me.
Okay, here at the top now. I did the refresh of the screen. So here I'm executing against the same inventory my switchover command, and I'm telling it pick the candidate number 3. I know the candidate name from previous list command here, right? Let's execute this playbook here. Hey, this is the current setup, and it's executing the switchover, and switchover happen. As you can see, multiple things happen here. First thing is that, as I was saying earlier, we pulled the plug. PG1 is stopped. We promoted PG3 as requested. It started running. It's still not done yet. Let's look at the list again. There you go. Now, as Postgres changes its role, it also changes the timeline. Here, timeline switch happened. This node joined back in the cluster. This node was reconfigured to become a replica node. And there is no lag in replication here. What if I have some sort of data loss? Running 11 version of PostgreSQL here. Once I remove this everything from my data folder, my DB is gone from this replica node. Patron is going to look at that and stop that cluster immediately. If I do a list here, that was too fast. Nowadays systems are too fast, you know, with PCI-based SSDs. Let me show you a log file, what happened here. Restore log. Before I open that log file, I can also show you one more thing here. Pacific time zone in San Diego. So it's 5:28. Let's look at the log file here. At 28:35, Petroni automatically called a restore. And it talked to backrest, restored all of my Let us back up, connected that node back into the cluster, and I have my HA cluster running again. It happened so fast because my DB was small. Looks nice, right? What if my process dies? Take a link for your database binary here, but for demo, why not, right? Here my Postgres is running. My PID is here 11874. In this case, it doesn't have to restore. It will just try to bring up that node again, and it will be able to, since there's no issue with the data folder, it's going to bring it again and reattach it to the cluster. So it started the node and it's back in the cluster here. So far, we are only talking about a replica node, right? What happens if we have, what if my primary goes down? So from this list, as you can see, 36 is the leader here. So I'm going to shut down this node. Look at the list again. It detected it stopped. Our leader has already been elected. It's been promoted. Timeline changed to 3. And it's going to connect number 16 also. Meanwhile, if I start by that node that I've shut down, it will come back and join as in the cluster. So I'm going to, on other terminal, I'm going to start that node. I started that node. Let's do up arrow here and look at the list. These two are already in a cluster working. And let me SSH here. Okay, I'm in. And let's look at the list here. There you go. Connected back. So far looks good. What if there's a complete loss of my data folder on PG2? Same thing will happen. Patroni will try to revive that node. It fails. Then it's going to promote one of the node to be leader and make that as a read-write node, promote it, and fix that old leader to become a primary, become a replica. Other things, we have written a couple other playbooks also. Like for some reason, one of my node is lagging behind or something happened that it could not connect. So let's say PG3 is having some issues. I can execute a reinit command, e candidate equal PG3. With this command, reinit command, Patron is going to go remove PG data from PG3, stop Postgres, remove PG data, restore from backup, restart PostgreSQL on that node. Right now it's good. I'm going to execute this command, and while it's running, let's look at the list multiple times here. Okay. Running too fast. No, it failed actually. Date equal to PG3. Again. Oh, actually, I'm on an old version of Patroni, which doesn't support the wait option, which we recently added here. So that's why it's failing. I can quickly get to the new version of Patroni here and see if I can show you the renit here. On version 11. Now, I try to do most of the things using these command lines. Playbooks. So I'm going to set up a local repository with a newer package for Patroni. I'm on my 3 node here. Okay, everything looks good here. I'm going to limit my Patroni cluster and set up my local repository there, which gets me the new version of Patroni. So currently we have HA 1.7 released, and today we first tagged our 1.8 RC1 candidate, which uses new features from Patroni 1.6. Here's my Patroni 1.5, and I'm going to say yum. Let me copy this command line from here. I can execute same command on other nodes. This is one of the replica, so I updated one replica and restarted Patroni on that one. Let's look at the list again here. Yes, looks good so far. I'm going to go to my other replica and update /y, -y I mean. Good here, we're good here. On 2 nodes we are good. Now, time to do another switchover. So let me execute a switchover here. This time, let's go to PG1. So I'm switching that role so that I can restart Patroni on my old primary after updating it. Okay, it's completed. Let's go to the node number. Exit from here and execute my Patroni update here. Okay. So the way our service systemd service file is that it expects a cluster name, which is basically a config file YAML for Patroni, and that's what I'm passing using at. Okay, let's look at the list again. Everything is running, timeline 4. Now let's try that renit again. So PG3 is still a replica. I can rename that one easily. PG3. Looks nice. Any questions, comments, anything else I can explain?
For HA proxy, how does HA proxy know which server needs to be talking, which one is the leader?
Sure, I can explain that. So as you see this command here, list command, similar to that one, there is a REST API interface for Patroni. Curl local host colon 8009. My Patron is running on port 8009. Let me do -v here. HTTP 200 here. That means this is primary. Let's take this command and run on one of the replica. HTTP 503. This HTTP code indicates HA proxy which node is primary. So when it gets 200, that means it's a primary. Make sense?
Okay. Yep, makes sense. So Patroni is taking care of reporting which server is primary.
Because manager knows what's going on with his colleagues or employees, right?
Mm-hmm.
So we directly talk to manager and get the information. There is other approach also that Patroni allows some hooks, and you can install those callback scripts, but that more like as a virtual IP kind of thing. Most of the big organizations, they don't like to go with the virtual IP, so HA proxy or F5 load balancer or NetScaler.
So the same concept applies when you're doing across data centers?
HA proxy can go across the data center, but not the virtual IP.
Okay.
Take a backup also, physical backup. I can execute this playbook and it will take a backup for me. And I'm connected here. I can show you BT backrest interface too. So there was a full backup and a differential backup, 1742. And my backup has already completed here. Yes.
Yep. So question with backups, can PG backup or whatever you're using, can it leverage the replicas to do those backups so the load on the read-write master node is not going up or going through the roof?
A good question, and answer is yes. I will explain it to you here. So here, this is my backup log here. So if you look at my options here, one of the option is backup standby configured here. If I go back to this node here and look at the list, my 16 is the leader here, right? That means this is read write, 26 and 36 are replica. Let's go back to backrest log files and see. Up to here, if you see, it's copying things from 16. And then it switches to 26 for everything else. It's not adding any load during backup on 16, which is primary. Good?
Yep. Another question. So as transactions are happening on your read-write node, does the backup insert a point in time so you can restore to a point in time? Or, well, I guess I'm seeing it right here, so I'm guessing the answer is yes.
Answer is yes. Let me show you a couple playbooks that we have here. Here's a physical restore if you just want to restore to the latest. And here this playbook can help you do single node point-in-time recovery. That means you can restore on a node and go back. You can define what timeline or what LSN you want to go to. I can do that. In case, let's say, if you want to go back in time for the whole cluster, that means all the 3 nodes you want to go back. There is a playbook here, whole cluster point-in-time recovery playbook. Not only that, we have playbook for different minor upgrades, and we support 2 type of upgrades. A rolling upgrade, that means update all the replica, switch over, and update remaining node, which is now a replica. Other option is you can do pause and resume, update all nodes, pause all the incoming connections, restart Postgres, and resume. That feature is available if you're using PG Bouncer. Other playbooks here is if you want to just do a PG dump, logical dump. So these are a couple different formats for logical dump. All these playbooks are here. This is the 3-node playbook. We have all other playbooks available, my 2-node, 3-node. And so far I've been only talking single data center. You can do similar setup on multi-data center also. That answers?
Yep, that answers. More questions from my side. So one of the things that a lot of customers do want is being able to make copies of an existing database for, say, development. So provide the developers with a database at a point in time so they can use that, and then later on they just destroy it. Is this something that could be leveraged through backups, restoring into a new cluster from an existing cluster?
Yes. So this single node point-in-time recovery can be used to restore it on any node. Of course, you have to have Postgres there. So we have a couple other playbooks in this are couple playbooks here. Like if I want to set up a single node with backrest, I can run this playbook. It will install my software, configure everything. Or I just want a Postgres node here. I can run this playbook. Then on top of that, I can execute this single node point-in-time recovery playbook and restore backup here. Make sense?
Yep, perfect.
I've been doing database for a long time, so I've been there. I'm like in '99, I did my Oracle certification as a DBA, but I like doing Postgres most of the time. I've been in that shoes. I know what the pain is, what the bottlenecks are. I'm open for questions if anything else. So currently with new version 1.8, which is coming start of a spring, today is the start of a spring, and it was a good opportunity for me to talk about HA and create a new HA cluster today. So in 1.8, we are bringing a lot of new features. In 1.9, we will be also bringing a new feature for major upgrades.
Replication, question about that. Are you doing table level replication, row level replication?
We are doing streaming replication. That means the whole cluster is replicated. We are not on the logical replication. Our start for this HA was related to Tower, Ansible Tower. And that time, Ansible Tower was only 9.6. We couldn't implement logical replication. Logical replication started after 9.6. It came in 10.
Okay.
But we do have a plan to incorporate logical replication. It's still in a development phase. Anything else I can explain, show? Anybody? So one thing with this whole design is that in-flight transaction is always going to be lost. Application has to retry that. There's a tool called PG Pool that can be used to determine read versus read write. But most of the time, my personal experience is that you get a lot of false positives. So any queries that are using function in those ones, they are always sent to read write node. So it's better always to have application understand these are read only, read write, and they can redirect those calls directly to write nodes. As you go across data center, network latency kicks in. You have to make sure your HCD timeouts are set up properly, your heartbeat for HCD. And not only that, but 20 timeouts needs to be tweaked. What we provide is a basic deployment. Usually when someone comes to me and says, we need HA, first we try to understand what are your requirements. Do you need a single node failure capability? Do you need multiple node failure capabilities? What you're looking for. With 3 node, you can sustain 2 failovers. There's a way I can just run whole HA cluster on 3 nodes. But that setup is not going to give me that kind of resilience what I'm expecting if I'm thinking of it can sustain 2 failovers. Because let's say if my common node is dead, what happens? I don't have a HCD third node because I only have 3 nodes, right? And now if another node fails, there won't be any Postgres available. If my one of the Postgres node goes down, yes, I have one failover opportunity. So it all depends on how resilient you want your HA, what are your needs. Based on that, the recipe is going to be different. It's not like one size fits all thing. Each database is different, each HA requirement is different, each cluster is different. Thank you, everyone. Back to you, Josh.
Yeah, does anybody else have any questions? Going once? Going twice? Can you guys hear us? Yeah, okay. Cool. Well, thanks so much for presenting that. Oh, go ahead.
Very nice job is all I was going to say.
Thank you.
Yep, very good.
Yeah.
Very informative, and look forward to being able to use it. Is along the lines of what I've seen with Oracle. So being able to see this happening in open source is encouraging.
Yeah, and obviously a big thank you to the Crunchy Data people. I know this was kind of a little bit of a non-traditional presentation. I really appreciate you guys stepping up and going to bat and presenting about this, because this was actually really cool. And I think this is something that hopefully we see a lot of adoption of, because it's sweet. Also, it has Ansible in it, which is great too. So, does anybody have any final questions?
No real questions. I will say this worked out pretty well.
I think so too. So
Who'd you install that?
It's the off-peak hours to make it fly. So
I was also going to say that the Yep.